Hi guys, welcome to the STEM section of QuizTikTime channel. In this section, we will learn about science, technology, engineering, and math. We are going to have a lot of fun doing these experiments. Let us start and have a lot of fun.
And let's do a countdown. 3, 2, 1, Hi friends! Do you know what, guys? I got this COSI Learning Lunchbox from the Ohio State Fair. This includes a lot of science experiments and many fun stuff for us to explore in here. Let's open it. I'm so excited! Oh, so this is about space. This is cool. Oh, we have a quote from NASA. All that we build, all that we study, all that we do prepares us to go. That's cool. Oh my God, look at this. There's some materials that we need to do so much fun experiments. Let's open it up. Ooh, you have a coffee filter? I wonder what that's for. We have this cup with rocket stickers on it. That looks cool. We have a balloon, some string, safety glasses, of course, safety first, a ping pong ball, and so much more. Next, let's see, a space activity book. There's 5 experiments in here. So much fun experiments. I wonder what experiments there are. We have so much fun learning to do here. Wait, I think I see something. A passport to the color of science. It has facts about different astronauts. Let's see what else we have. This book has 5 amazing experiments. Let's learn how to do them and dive right in and have some fun and learn new things about science. Let's go!
The 5 activities are: number 1, build a balloon rocket. Number 2, make a parachute. Number 3, 3, 2, 1, pop. Number 4, build the base. And number 5, impact craters. Let's get started with these amazing fun science experiments. Now we're going to learn the process of doing experiments. Of course, safety first. You need to wear lab coats or safety glasses if you have any. Do all these experiments with the help of elders. I did these experiments with my dad's help. Of course, one important thing is to question and understand your objective of the experiment. Make hypotheses. Of course, get your supplies too. You need all the supplies you need. Follow steps, an important thing. And of course, observe. That's amazing. It's nice. I like observing. And conclude. Connect to real life examples. And number 6, innovate. Now let's do some experiments.
Hi friends! Today we're going to do the experiment called Launch the Rocket. And we're also going to learn Newton's third law. So for this experiment, you need 2 rods or chairs, anything you would like, and some string, a balloon, a straw, and a paper clip. And some tape, or we're using some stickers. So first, you have to take your 2 rods, as we did, and tie a string together of each other like this. One, tie it over here, and there, to make a line. and then make sure your straw is on while you're doing that. And you also need to blow a balloon, but do not tie it. After you're done blowing a balloon, take the paper clip and pin it onto the side of the balloon so it doesn't blow any air out. So we're going to think that the star of the string is going to be Earth. And the end is the moon. It's like as if we're launching a rocket to space. So now we're going to launch it. 3, 2, 1. And let's do a countdown. 3, 2, 1. This is Newton's third law. The force of air blew out this way, but the balloon went forward. That's Newton's third law. Every action has an equal and opposite reaction. Thank you, guys.
Let us see how Newton's third law is used in our real life. Rockets. Rockets move forward by expelling gas backward at high velocity. This means the rocket exerts a large backward force on the gas in the rocket combustion chamber, and the gas therefore exerts a large reaction force forward on the rocket. This reaction force is called thrust. We will see more about rocket takeoff later in this video. Bouncing a ball. When a ball hits the ground, the ball applies an action force on the ground. The ground applies a reaction force and the ball bounces back. Firing of a bullet. When someone fires a gun, the action force pulls the bullet outside the gun, and the reaction force pushes the gun backward. Helicopters and birds. Helicopters similarly create lift by pushing air down, then experiencing an upward reaction force. Birds and airplanes also fly by exerting force on air in an opposite direction. For example, the wings of a bird force air downward and backward in order to get lift and forward motion.
So now we added a marble inside. There's more weight in it. Air is like a fuel, so the more air we keep, the faster it goes. But we added a weight, a marble. So will it go slower? Think as if there's an astronaut in this rocket. So now we're going to launch it again. 3, 2, 1, go.
Oops. The marble came out. It is not supposed to come out. So what we learned here? We need correct math to understand the speed and mass of rocket going through the atmosphere. This is very important because, if it doesn't get enough speed, the rocket will burn up and crash back to Earth. Many rockets burned up before they had the right mathematical solution. And physics plays a crucial role, from launching satellites into orbit. So kids, the design of rocket needs physics and mathematics. I hope you got this. The mass of a rocket is important for 2 reasons. So what did we learn? Newton's second law. Newton's second law of motion sums up this idea. This is often stated as force equals mass multiplied by acceleration. An object with less mass accelerates more quickly, and an object with more mass has more gravitational force acting on it, so accelerates slowly. For larger rockets that are meant to travel into space, launched in multi-stage approach, powered by engines with propellants, oxygen and a combustion chamber, is required. The primary stage of a rocket is the first rocket engine to engage, providing the initial thrust to send the rocket skyward. After the primary stage has fallen away, the next rocket engine engages to continue the rocket on its trajectory. If the rocket has additional stages, the process will repeat until the rocket is in space. Once the payload, whether it be a satellite or a spacecraft, is in orbit, the rocket's final stage falls away. Okay.
So now we're doing 2 balloons. Let's see what will happen. Both of them are applying a force to each other. One balloon's letting air out this way and the other's letting air out that way. And they're both heading, this one's heading towards the orange balloon, while the orange balloon's heading toward the green balloon. Let's see which balloon has more force to it. 3. So now,
Hi guys!
Today we're going to make a parachute. For this experiment, you need a cup, a coffee filter, hole punch. So you're going to hole punch the coffee filter and the cup, and then you're going to tie them together with string. And we're going to watch these little astronauts make their landing in space. So, hole punch 3 sides of the coffee filter. Then you're going to tie the string and the hole punched coffee filter and the string together to make a parachute. Okay, I'm done tying. In the end, it should look like this. 3 knots of string tied up to the coffee filter, and then those strings tied down to the cup. Now you're done with your parachute.
What next?
Oh, what next? Now we have to take it outside and test it. We'll see you there.
Great job, kids. Good try. What we learned from this experiment. During its launch phase, the shuttle had a powerful main engine and rocket boosters to power it into space. But when it comes back again, drifting through the air, gravity pulls objects straight down towards the center of Earth. It is strong enough to make falling objects move quickly, creates hard landings. But luckily, we have a layer of air around Earth which slows fall. So parachutes slow the capsule or spacecraft to perform a soft landing. And recovery teams will be standing by to retrieve the capsule. Parachutes fly by Earth at the right time to release the capsule. Apollo 11 first landed humans on the Moon and returned them safely to Earth's surface. Neil Armstrong and Edwin Buzz Aldrin were the first of 12 human beings to walk on the Moon. Crewed spacecraft still use parachutes to bring astronauts and cosmonauts back to Earth. SpaceX's Crew Dragon and Russia's Soyuz capsule are 2 recent examples of soft landing. Now that you learned how parachutes help for soft landing, let's move on to next activity. Okay, kids, now your turn.
Hi guys, now we're going to do the 3, 2, 1 pop experiment. This is part 1 of the experiment, cold water and antacid mix. The supplies you need are a plastic container with lid, cold water, antacid tablets. You need exactly 1/4 of it. And safety glasses. Safety first. Now, you have to pour the cold water into the plastic container. This next step, as Take your 1/4 of the antacid tablet. Drop it into the container. The antacid tablet and water react to create a gas or carbon dioxide. Cool!
Safety first. Where are your safety glasses? This time we're doing the same experiment but with some hot water. Take another half of your antacid tablet. Pour the water in. And then add your tablet. Continue to wear your safety glasses. Now take your water and pour half of it into the cup. Now, very carefully, take all the halves and step back a bit when you're doing this. Take all the halves, pour it. Oh, Daddy, I'm scared. Close the cap. And flip it!
Thank you, kids. What we learned from this activity. When we mix water and antacid, the antacid tablet and water react to create a gas CO2, or carbon dioxide. Which one expands to take up more space? Gases. There just wasn't enough room in the capsule for all that gas that was created. The pressure built up until the force on the capsule was strong enough to push off the lid. For every reaction, there is an equal and opposite reaction. The container exerts a downward force on the carbon dioxide and the carbon dioxide exerts an upward force on the container, throwing the rocket up into the air. Rocket exerts a large backward force on the gas in the rocket combustion chamber, and the gas therefore exerts a large reaction force forward on the rocket. This reaction force is called thrust. Let's move on to next activity. Okay, kids, now your turn.
Hi guys, today we're going to do the 4th experiment, build a base. The supplies needed is Play-Doh and toothpick. After you blast off into space and land on the moon, it's time to use your engineering skills to build a moon base. With your Play-Doh and toothpicks, just build 3D shapes and any shape you want.
Thank you, kids. Living on a lunar base will give us clues about how humans could cope on a foreign celestial body, with a negligible atmosphere and more dramatic temperature fluctuations. A lunar base station could also serve as a great site for future astronomical observations. NASA is planning a permanent moon base. A launch pad is an above-ground facility from which a rocket-powered missile or space vehicle is vertically launched. Horizontally integrated rockets travel horizontally with the tail forward to the launch site, on a transporter erector launcher, and are then raised to the vertical position over the flame duct. There are many rocket launch sites across the world. Some of the examples are Launch Pad at Kennedy Space Center, Florida. Satish Dhawan Space Center, Andhra Pradesh, India. Why engineering design process is important for any projects. The engineering design process is a series of steps that engineers follow to find a solution to a problem. It could be any problem. It is a cyclic process with below steps. Brainstorm ideas, plan, build, test, or evaluate and share. Modify and improve until the solution meets the needs of the project. This is iterative process and is a common method of working.
Hi guys, today we're going to do the experiment called impact craters. For this experiment you need a paper napkin, some flour, cinnamon, a ping pong ball, marble, rock, and some rulers. First, you need to take some flour and spread it across your napkin. You can spread it with your ruler. Or you can use a spoon. Next, you're going to pour some cinnamon around the flour. Now you're going to drop each ball. Okay, no. And a rock and a marble too. So now you're going to carefully lift them and measure the dents they made. Asteroids also make these dents, but they're very bigger. So this is where your rulers come in. You want to measure each of the dents. I'm going to measure in inches. This one's about 1 inch. The rock is about ½ inch. And the marble is about ½ inch too. Thank you guys for watching this video. Hope you have fun making this at home.
Thank you, kids. Good job. How this activity related to space. Have you ever seen craters photos? For example, the marble, rock, ping ball are forming dents on the flour, which we measured and saw the different sizes. Same way when the rocks from space hit a planet or moon, craters or dents formed on the planets or moon. How craters helps astronauts. When astronauts visit the moon, they will be studying the craters to see if there is water or ice on the moon. Impact craters occur on every planetary body in our solar system, no matter the size. Many impact craters on Earth have been erased thanks to wind, water, and plate tectonics. But scientists have clever ways to find them. As satellite imaging datasets become readily available at even higher resolutions, we are able to identify more potential impact structures in remote areas. Field geologists could explore these and search for the structures and chemical signals of an impact. Each crater, no matter how old or how obscured, it is ready to teach us something new about our planet, our solar system, and the geological processes that shape it. Some of impact craters are Lonar Crater in Maharashtra, India. Barringer Crater, also known as Meteor Crater in Arizona, USA. Wolf Creek Crater in Western Australia.
Which is the largest planet in the solar system? Jupiter. Which planet is closest to the Sun? Mercury. Who was the first man in space? Yuri Yuri Gagarin. What is the approximate temperature at the surface of the sun? 5,500 degrees Celsius. What is the name of the force which keeps the planet in orbit around the sun? Gravity. Which planet has a day which lasts 8 months? Venus. First human to walk upon the moon is? Neil Armstrong. How many moons does Earth have? 1. Name of the spacecraft India launched recently onto the moon in July 2023? Chandrayaan-3. Newton's second law formula is? F equals m times a. Thank you guys for watching. I hope you liked the video. We will be coming up with a new space quiz and many more STEM projects. Keep watching!
Thank you for watching. I hope you enjoyed. Don't forget to subscribe, share and like to get notifications. Check out the links below for more quizzes.